Hello children, today we are going to do chapter metals and non-metals. This is third chapter of class 10 from NCERT book. What are metals? Metals are things around you which are having shiny surface like gold, silver. They are hard, iron, copper, but we are having exceptional cases like sodium, potassium. These are soft metals. They can be easily cut with knife. They generally exist in solid state. Exceptional cases, mercury. Mercury we can find in our mercury thermometers in liquid form. Metals are generally malleable. They can be beaten into thin sheets. We can hammer them and convert into thin sheets and make our things accordingly. Then gold, silver are most malleable metals. Metals are also ductile in nature. Ductile means they can be stretched to form wires. Malleable means they can be beaten into sheets, and ductile means they can be stretched to form wires. Metals are good conductors of heat and electricity. That's why our cooking vessels are made up of metals because they can conduct electricity. Examples are silver, copper, which are best conductors. Then density. Generally, metals have high density and high melting point. And exceptional cases are sodium, potassium, lithium, which are having lesser density. Metals are sonorous. Sonorous means when we will struck them with something, they'll produce a ringing sound. That's why metals are used to make bells. Oxides of metals are basic in nature. You must have seen magnesium ribbon when burns in presence of oxygen, it forms magnesium oxide. Magnesium oxide when reacts with water, it forms magnesium hydroxide, which is basic in nature. Then comes to non-metals. Non-metals, they don't have shiny surface. They are generally soft. Exceptional cases, diamond. Diamond is the hardest non-substance which is used to cut glass. They generally exist in solid and gaseous state. Exceptional cases, bromine. Then malleability, metals are non-malleable, non-ductile. If you will take a piece of coal or charcoal, it can't be beaten to form thin sheets or it can't be stretched to form wires. Non-metals are poor conductors of heat and electricity. And exceptional cases, graphite. Graphite is good conductor of heat and electricity. Here it is not example, it is exception. Graphite is exceptional case. Then comes to density. Density, non-metals are low density, low melting point non-metals. Then sonority, non-metals are non-sonorous. When you will strike with something, they will not give you ringing sound. And oxides of non-metals are acidic in nature. Like carbon burns in presence of oxygen, it forms carbon dioxide. Carbon dioxide, when combines with water, it gives you carbonic acid, which you are using in your cold drinks. In cold drinks, we are filling compressed carbon dioxide gas. It gives you tangy taste. Then come to chemical properties of metals. Metals, when combined with oxygen, they form metal oxide. Like simple example, we are taking magnesium ribbon burns in presence of oxygen. It will give you magnesium oxide. Magnesium ribbon when burns in presence of oxygen, it gives you magnesium oxide. Magnesium oxide is basic in nature. If you want to check its nature, what you have to do? Magnesium ribbon you have to take. When you will burn it in presence of oxygen, it burns with dazzling white light to form white ash. This white ash you have to collect and add water in it. It will give you magnesium hydroxide. Magnesium hydroxide is basic in nature. You can check its nature with the help of litmus paper. Red litmus paper will turn to blue, which is confirmation it is base. Similarly, if you are taking copper turnings and burning it in presence of oxygen, it will give you copper oxide. Brown color of copper will turn to black copper oxide. Aluminium burns in presence of oxygen to give you aluminium oxide. If you are finding any problem in writing the formulas, you should know the valency and then you have to crisscross. Like aluminium 3 positive, oxygen 2 negative. You can crisscross them. It will give you Al2O3. That is formation of aluminium oxide. Different metals show different reactivities towards oxygen. Like sodium and potassium react very vigorously. They can catch fire. So we have to keep them under the kerosene oil. Surfaces of magnesium, aluminium, zinc, lead are covered with thin layer of oxide, which prevents their further oxidation. Iron does not burn on heating, but iron fillings burns vigorously. Copper does not burn, but coated with black copper oxide. Silver and gold doesn't react with oxygen as they are considered noble metals. Some of the oxides of metals are amphoteric in nature. Amphoteric means in presence of acid they will behave like base. In presence of base they will behave like acid. Like here you are taking aluminium oxide, reacting it with HCl. It gives you aluminium chloride plus HCl. You can write this reaction. Aluminium oxide you are having aluminium, 2 atoms of aluminium with the 3 atoms of oxygen. They are reacting with 6 molecules of HCl. So it will form AlCl3 because valency of aluminium is 3 positive. So 3 atoms of chlorine will react with it. It will give you AlCl3 and it is again forming AlCl3 in this way. 2AlCl3 you are getting and they are forming water. This is H2O. This is again H2O. This is H2O. So this is formation of 3 water molecules. Balance it in this way. Aluminium oxide when reacts with NaOH, it gives you sodium aluminate plus water. You can write this reaction again. Al2O3. It will give you NaAl O2 We write it again. It is Al2O3 and NaOH. It will give you NaAlO2. NaAlO2, NaAlO2, leaving behind H2O. In this way, you will get this product. Then we have chemical properties of metals. Metals, when reacts with oxygen, they form metal oxides and liberating out hydrogen gas. Metal oxides, when react with water, they form metal hydroxide. Like sodium metal, when comes in contact with water, it gives you NaOH plus hydrogen gas. Along with that, immense amount of heat energy is produced. Because of that, hydrogen gas immediately catches fire. It seems like sodium is catching fire, but no, sodium is not catching fire. Hydrogen is catching fire in this reaction. Calcium, when comes with in contact with water, it gives you calcium hydroxide plus hydrogen. Calcium hydroxide starts floating in this process. Iron, when reacts with water, gives you iron oxide plus hydrogen gas. In this reaction, sodium reacts with even cold water very vigorously. Very vigorous reaction is this. Calcium reacts with ordinary water and iron reacts with steam to form Fe3O4. Different metals reacts with different forms of water. See, sodium, potassium, calcium reacts with cold water. Aluminium, iron, zinc reacts with steam. Magnesium reacts with hot water. Calcium, magnesium start floating on the surface because hydrogen gas stick to their surface and being lighter in weight, it comes on the surface. Then gold, silver, copper, lead doesn't react with water. Chemical properties of metals. Metals reacts with acids to form salt plus hydrogen gas. Like you are having aluminium plus HCl, it gives you aluminium chloride plus hydrogen gas. This is the same equation we have discussed in amphoteric processes. Then reaction with solution of other metals like iron react with copper sulfate to give you iron sulfate plus copper. This is displacement reaction where a more reactive metal displaces less reactive metal from its salt solution. To know this, you should know reactivity series. Reactivity series we have already discussed with displacement reactions. That is, this is reactivity series. We can learn it with the help of trick that we have already discussed with chapter 1. That was Kedar, Nath, Ka, Munshi, Alu, Zara, CK, Se, पकाता है क्योंकि हर आदमी आलू पकाता. The elements which are present on the top are most reactive. The elements which are present in the middle are moderately reactive. And the lowest elements, these are least reactive. Every element which is present on the above, like the sodium can replace calcium from its salt solution. That is displacement reaction. Reaction of metals with non-metals. Like metals are having 1, 2, or 3 electrons in their outermost shell, which they can give out and get the noble gas-like configuration. Similarly, non-metals are those which are having tendency to gain electrons, right? So metals are Maharajas. Maharaja means who is having capacity to gain something. And non-metals are Nang. They are having tendency to gain something, right? So metal will give electron and non-metal will always accept electron. Like here in sodium, you are having 281 configuration. Means it is having one electron in outermost shell which it can donate. Here we have to write 1 along with it. It is 281. So if it will lose one electron, it will get noble gas-like configuration. So sodium wants to lose one electron from outermost shell and chlorine wants to gain one electron from outermost shell. That's why they will get ionic bond. We can draw it like we are having sodium 281, chlorine 287, sodium is having one electron in outermost shell, chlorine is having 7 electrons in outermost shell. Sodium wants to give one electron to chlorine to attain noble gas-like configuration. After giving this electron, sodium will be now 28, that we call as Na positive. And chlorine will gain one electron, it will turn Cl negative. It is 288. So its configuration will be now stable, noble gas-like configuration. This is formation of NaCl. Sodium is giving one electron to chlorine. It is completing its octet. It is completing its octet by gaining electron. There is formation of AlCl3. Aluminium is having 3 electrons in outermost shell, which is shown by this cross. And chlorine atoms, they are having 7 electrons in their outermost shell. So aluminium will give 3 electrons to 3 chlorine atoms, 1 to each, and it will make this structure AlCl3. Properties of ionic compounds. Ionic compounds are generally hard solids. They are brittle in nature. They are having high melting and boiling point. They are soluble in water but not in organic solvents like kerosene, petrol. They are not soluble. They are good conductors of electricity in their molten state or in aqueous solution, but in solid form they will not be able to conduct electricity. Reason behind is in structure of sodium chloride, every sodium ion is surrounded by 6 chloride ions. So these ions are not free to conduct electricity. When they'll be free in their molten state, when you will melt sodium chloride, the ions will be free. Process how we can melt sodium chloride. What you have to do, you have to take a bowl and you have to put sodium chloride in it. Then using a double boiler system, you have to take a big container and put boiled water in it. Then keep your salt in it. With the help of boiling water, the sodium chloride will melt, just like we melt chocolates. In case of solubility, see, we are having water. Water is a polar solvent, right? In water, you are having H2O, oxygen end is negative, and hydrogen end is positive. In NaCl, we are having Na positive and Cl negative. Around sodium ions, oxygen atoms will come. It will make this type of structure. Oxygen atoms will surround sodium atom from water molecule like this. And hydrogen end will come towards chloride ion because hydrogen is bit positive in nature. It is positive end in water. So hydrogen ions will start coming near chloride. In this way, sodium chloride will become soluble in water. Then we are having extraction of metals from its ores. In nature, we are getting minerals. Minerals means a big lump. From nature, you can get them. These are compounds you are getting from nature itself. They are found in the crust of earth. You can find a big piece from which you can extract metal. But how much metal you can extract from it? What would be the cost of extraction process? You are not sure about it. So you are going to get economic benefit from it or not. It is not sure. At that time it is mineral. And when you are finding that big lump, a big piece from which you can separate metal, and you are extracting the one part of it, that is, it is not having much metal in it. And the other part, which is having more concentration of metal in it, is considered as ore. The separation of metal from ore will be always economically beneficial. Minerals that are containing high percentage of particular metal means आपको एक बड़ा सा lump मिलता है, उसमें से आपने एक पीस काट दिया जिसमें मेटल की कंसंट्रेशन बहुत कम है, तो the other part you are getting is having more concentration of metal is considered as ore. Then ores are containing some contaminants with them in large impurities like soil, sand. These are called gangue particles. What would be the processes to extract metals from their ores? First is enrichment of ore, then extraction of metals, then refining of metals. We will discuss them one by one. In first step, we are having enrichment of ore. What you can do to enrich, it is hydraulic washing, washing with water, magnetic separation, froth flotation, or chemical separation or leaching. It is what chemical here. In hydraulic washing, what we are going to do, it's process of gravity separation. First thing, we have to convert your lump into fine powder, and then you have to wash it with the help of water. Here we are using a sloping hearth, right? In sloping hearth, you are having at different steps. Then this is dissolved in water. This powder is dissolved in water. You can find that metal being heavier will start settling down, and impurities, if they are lighter in weight, they will start floating on the surface. As we are washing wheat at home, they are having some husk particles. So when you are putting water in it, husks start floating on the surface, and you can wash off it and you can dry the grains. Similarly, here we are doing washing. In this process, metal will start settling in these stairs and impurities will start floating on the surface, which you can wash off. Then you have magnetic separation. It is used for metals like iron, chromium, manganese, magnetite. In this process, we are using a magnetic separator. Here you are having two wheels. This wheel is non-magnetic and this wheel is magnetic. And this is having a conveyor belt over it. You are taking this powder and it is start moving with the conveyor belt. Then magnet will attract magnetic pieces towards itself and non-magnetic things, that is impurities, will be repelled by it. So you will get two different heaps at different places, that is magnetic things here and non-magnetic things here. This would be the process how we can enrich the metal. Then comes froth flotation. Froth flotation is used for sulfide ores. You are having zinc sulfide, copper sulfide, then we are using this froth flotation process. Here we are using light oils like pine oil we are using here. We are keeping this ore in a water tank and putting pine oil in it. Then with the help of a rotator, we are rotating it. When you will rotate it at very fast speed, you will get froth coming on the surface. You can remove the froth which would have your metal, and impurities being heavier will start settling here. They will be in the water. Here the procedure is basically that oil is wetting the metal with it. Means metals are wettable by oil and young particles are wettable by water. So you will take out the froth and dry it. It would have maximum quantity of sulfide ore, leaving behind all dust, soil and other impurities present in it. Then we have chemical refining or leaching. In this process, we are reacting metals with some other chemicals to make their concentration high. Like you are having zinc sulfide, we are reacting it with sulfuric acid in presence of oxygen. It will give you zinc sulfate plus water plus sulfur. Extraction of metals which are low in reactivity. Metals which are low in reactivity are in the form of sulfide ores. For sulfide ores, we are doing roasting. In roasting, we are reacting zinc sulfide with oxygen. It will give you mercurous oxide plus sulfur dioxide. Mercurous oxide, when heated, will give you mercury plus oxygen back. Similarly, copper sulfide, when reacts with oxygen, will give you copper oxide plus sulfur dioxide. Copper oxide is again added with copper sulfide a little bit. It will give you copper plus sulfur dioxide. This copper metal which you are obtaining by this process is called blistered copper. Why blistered? Because there would be blisters on the surface. There would be cracks on the surface. As sulfur dioxide gas is liberating from it, sulfur dioxide needs some space to move out. So that space is created by making cracks on the surface. So copper metal you will have here as blistered copper. Then extraction of metals which are middle in the reactivity series. In the middle of reactivity series means moderately reactive metals. They exist in two forms, as sulfide ore or carbonate ore. In case of carbonate ore, we will heat them in absence of oxygen. That is called calcination. You have to keep in mind calcination for carbonate ore. Both are CC. कार्बोनेट और की कैल्सिनेशन करेंगे, right? So you have to heat it in absence of oxygen. When you will heat them in absence of oxygen, carbon dioxide gas will evolve out. Like you are taking zinc carbonate, ZnCO3. When you will heat it in presence of oxygen, in absence of oxygen, you will get zinc oxide plus carbon dioxide. CO2 is coming out and you are getting metal oxide. And if it is in the form of sulfide ore, we are doing its roasting. RS, roasting for sulfide ore. Roasting means heating in presence of oxygen. जैसे पनीर टिक्का बनाते हो, heat करते हैं in presence of oxygen. Zinc sulfide plus oxygen will give you zinc oxide plus sulfur dioxide gas. In both the cases, you will get metal oxide. Means carbonate will give you oxide and sulfide will give you oxide. In case of carbonate, we have to use calcination. In case of sulfide, we have to use roasting. Then reduction of metal oxides to metal. For converting it into metal, we need some reducing agents. These reducing agents can be coke, carbon, carbon monoxide, and hydrogen. When you are using carbon, coal, or coke as reducing agent and treating it with metal oxide, you will get carbon monoxide. Carbon monoxide gas you can't release out in atmosphere as it is silent killer. When it goes to your bloodstream, it reaches to your brain, it will not let oxygen to get in, so you can suffer from brain hemorrhage, right? You can have that problem. So carbon dioxide gas you can't release out. That means carbon monoxide gas has to be again used as fuel, it has to be again used as reducing agent. So at different temperatures, carbon and carbon monoxide will act as reducing agent in the same furnace. And we will liberate out carbon dioxide, not carbon monoxide. Then extraction of metals which are top on the top in reactivity series, like sodium you are having. Sodium is you are having in the form of sodium chloride, NaCl. You will take sodium chloride in a big container, then you will insert two electrodes in it. That is positive and negative, and we will join them with battery. Sodium chloride will furnishes Na positive Cl negative ion. Na positive will start moving toward the negative terminal, Cl negative will start moving towards the positive terminal. So you will get Na positive plus electron will give you Na, Cl negative minus electron will give you Cl. In this way, you will be able to separate sodium and chlorine from sodium chloride. One thing you have to keep in mind, you can't use here aqueous solution of sodium chloride. If you will use sodium chloride aqueous solution by mistake, you will not get sodium and chlorine, but you will get NaOH plus hydrogen plus chlorine. That was chlor-alkali process we have done in chapter acid bases. Last topic is corrosion. Corrosion is eaten up of the metals by atmospheric factors like air, water, and other impurities. Like silver is turning to black when exposed to moisture. Copper metal, when react with carbon dioxide, it forms green coating of copper carbonate over it. It is basically alkaline copper carbonate. Copper reacts with water, oxygen, and carbon dioxide to give you CuOH twice dot CuCO3. Iron, when exposed to moisture, acquires a coating of brown substance called rust. This same topic, corrosion, we have already covered with chapter chemical reactions and equations. It is the same thing. Then how we can prevent corrosion? To prevent corrosion, we have to remove one of the factor which is required for corrosion. For corrosion, we need basically three things: metal, oxygen, and water. If you will remove any one out of them, you will be able to save metal from corrosion. So the basic factor, we are making coating of oil, paint or grease over the surface of metal so that its contact with air can be broken. We are using galvanization or chrome plating or anodizing or making alloys. Alloys means mixing metals with other metals or non-metals so that they will not get more spaces for oxygen and water to get in. In galvanization, we are protecting metals by covering it with zinc. These are examples of alloys. In iron, we are adding carbon to make steel. In copper, we are adding zinc to make brass. In copper, we are adding tin to make bronze. That's all about this chapter. Thank you, children.